Hello everyone. Previous lecture we have studied the concept related with the chapter straight line, and in that we see the definition of locus, we see how to find equation of the locus, okay, and for this we consider some examples. Now in today's lecture we will go with the concept of the chapter straight line, and here is for shift of origin. Here we have to change the origin. So we have to consider new origin and old origin, and related with this part we have to define the new coordinates by using the old coordinates. Okay, so to define this part we consider one figure. Here we consider coordinate axis. Okay, so here we consider the x and y axis. Okay, here this is our x-axis, then we consider this as y-axis. Here origin is at O. Okay, here negative side of x-axis we denote by using here x dash, then negative side of this y-axis we denoted by using y dash. Let us consider here coordinates of origin. Okay, here coordinates of origin are, here I write for origin, here origin O 0 0. Let us consider one point related with this coordinate axis. Suppose this point is P, and P is here having here x and y, having coordinates x and y, small x and small y. Remember. Now if we draw the perpendicular like this, or we consider the dotted line to define the point P of xy. Okay, here is our point L. Okay, then on the y-axis we consider point here M. We consider here point M. We know this distance OL. Remember, here we know this distance OL is x. So here is distance x. Okay, then we consider the distance PL. Distance of this PL as y. Okay, so here is our y. This is the distance PL and is y. Okay, now we know this x and we know this small y, and by using this small x and small y we define P of xy. Now we have to shift this origin O00 to the new point. Let here origin is here. We shift the origin O00 to the point having coordinates HK. Okay, so related with this point we draw the coordinate axis. Okay, so here we draw the coordinate axis. And this coordinate, this is, okay, this is, suppose here is x1 dash and here opposite side is x1 and here origin is O dash. Remember, we shift this origin O to the point O dash and is having coordinates here HK, and is having coordinates HK. Here we draw the y-axis, and this axis is parallel to our first y dash, and here x dash O dash x1 is parallel to x dash O x, and here y dash is parallel to here y1 O dash, and here is y1 dash. Remember, so we shift this origin O to O dash. Now here h is the distance. Let's define one point. Let us consider this point is N. This point is N. Okay. So this distance I write here is H. Here is a distance H. This is our distance H. Okay. Then here for O dash N, I write here distance K. This is our distance K. So by using this H and K, we define this O dash. Okay. Now here we have to find the distance of this P. Here I write next point as O. This is our point. Sorry, we consider this point as Q. We consider this as Q. Okay. Now here we know this O dash Q is the distance, and let us consider this as here capital X. Here this as capital X. Then for here PQ, we define the distance. Here is capital Y. Here is capital Y. So by using this capital X and by using this capital Y, here we get new point and is having coordinate capital X, capital Y. So here is our point P. Here our old coordinates for point P are X, Y. If we shift this origin to O dash HK, then we get new coordinates of point P, and here are capital X, capital Y. Okay. Now here in the shift of origin, we have to define the relation in between old coordinates and new coordinates. That is relation in between the small xy and here capital XY. Now, if we see this figure, we know this OL is a small x, and if we consider this our new coordinate axis, here we get this x as h plus x. Okay, so here I write, here we get x, small x. Everyone see here, small x is x plus h, that is capital X plus h. Okay, then for small y, here we consider small y. We know the small y is the distance of PL, and here is this capital Y K, that is capital Y plus K, and this is the relation in between the old coordinates and the new coordinates, and we define this by using the same figure. Okay, so x small x is equal to capital X plus h, and y is equal to capital Y plus k. Here small xy is for old coordinates. Here capital X and capital Y is for new coordinates. Then here small h and k are for the new origin. Okay, so remember this part. Okay, here I write note, or I write directly here small xy. This point is for old coordinates. Then capital XY is for new coordinates. Then here HK is for new origin. Okay, so remember this. So by using this concept, we have to define, or we have to see some important examples. Okay, here remember, this is the formula for shift of origin. And by using these formulae, we see some examples. Okay, so we go with our examples. Example, here in first, we consider if the origin is shifted to the point to the point O dash 2 3, O dash 2 3, the axis remaining parallel to the original axis, find the new coordinates, of the point A13, So very simple example it is, and by using the formula for shift of origin we find our new coordinates. Okay, so here we define the given things. Okay, here I write firstly given things. Here O dash is for new origin. Okay, so here in the answer I write here new origin. Here new origin is equivalent to O dash HK, and here is given O dash 2 3. Then here given old coordinates. Here A is for the old coordinates. Okay, so old coordinates is equivalent to here A of XY. A point is given, so we consider this A, and this is equivalent to A of 1 3. Here we know small x is 1, small y is 3, we know h is 2, k is 3, and by using this part we define new coordinates. So we go with our formula for shift of origin. Okay, so by using formulae for shift of origin, here we get, firstly I write the formulae. Okay, here small x is equal to capital X plus h, and here small y is equal to capital Y plus k. We have to find capital X and capital Y. We know here XY, capital XY is for the new coordinates. Okay, so here I write capital X separately here as X minus h. Okay, then here I write this capital Y as small y minus k. Okay, now we replace here small x and h and small y and k. Therefore, here we get capital X is equal to, we know here small x is 1, so 1 minus, here h is 2, so 1 minus 2 and is equal to minus 1. And here for y, here for capital Y, we know small y is 3, so 3 minus, here k is 3 again, we know 3 minus 3 is 0. Okay, so we get here new coordinates capital X and capital Y, and are minus 1 0. Okay, therefore the new coordinates are okay, here minus 1 0. Okay, and this is we have to find. Very simple example it is. Let us see one more example by using the same part. Okay, here given, also again we consider the same example. Here we consider second point as B, and B is having coordinates here 2 5. B is having coordinates 2 5. Okay, now here again given the new origin O-HK and is O-2, 3. Okay, then here old coordinates are given. Here for old coordinates we consider B, so B of xy, and here B of xy is, here is B to 5. Here is B to 5. Again, by using the formula for shift of origin, here we know small x is capital X plus H and small y is y plus K. Here we have to write capital X separately. Here I write this as small x minus H, and for capital Y, here y minus K. Let's replace this XH and YK in the given relation. So here capital X is equal to, we know small x is here 2 minus, here small h is 2. Okay, this is equal to, we know 2 minus 2 is 0. Then here for capital Y is equal to, again we know y is 5 minus, here k is 3. So 5 minus 3 is equal to 2. We know 5 minus 3 is 2. Therefore, the old coordinates are, new coordinates are having 0, 2. Okay, so very simple example it is. Let us see another example. Let's go with next one. Here in the second, given if the origin is shifted, if the origin is shifted to the point O-1, 3, the axis remaining parallel to the original axis find the old coordinates of the point C54. Again, very simple example it is. Again, by using the formula for shift of origin, we find the old coordinates. Okay, let's define the old coordinates first. Let here P of xy, or directly we consider small xy are old coordinates. Okay, then we consider the given things here. Here given new origin is O-HK, and here O-1, 3. Then here given the new coordinates, here for new coordinates given C54. Okay, this is equivalent to here C capital X capital Y. Here for new coordinates we use capital X capital Y. Okay, we know here formula for shift of origin. Here x is equal to, small x is equal to x plus h, and small y is equal to y plus k. So by using the same relation, we find our old coordinates. Okay, so here I write small x separately. Here small x is capital X plus h. Capital X is 5 plus h is 1 and is equal to 6. We know 5 plus 1 is 6. Then here for small y we consider capital Y plus k is equal to, we know capital Y is here 4, so 4 plus k is 3, so 4 plus 3 is equal to 7. And finally here I write this as here old coordinates are, therefore old coordinates are here 6, 7. 6, 7. So very simple example it is. Remember these examples. Let's go with our next example. Here in third, if the coordinates A of 5, 14 change to B 8, 3 by shift of origin, find the coordinates of the point where origin is shifted. Okay, again we see example. Okay, here we have to find the coordinates of the point where origin is shifted. That is, we have to find the new origin. And for this, here old coordinates and new coordinates are given. Okay, so here we define HK, new origin first. Let O dash HK is new origin. Now we go with given things. Here given the old coordinates. That is, here A of 5, 14 is given, and his A here is A of small xy. Then we consider the new coordinates. Here for new coordinate given B of xy, that is B is equivalent to here B of 8, 3. Here we know small x, small y, we know capital X, capital Y. So by using the formula for shift of origin, we find new origin. Okay, so by using formula for shift of origin, here we get, firstly I write the formula. Okay, here small x is capital X plus h and small y is capital Y plus k. Here we have to find h and k, that is old coordinate, new origin. So I write h separately. Here I write h separately as small x minus capital X. Okay, then here for k I write small y minus capital Y. Okay, here we know small x. Is 5. So 5 minus capital X is 8, and here we get minus 3. Then here for k we know small y is 14 minus here capital Y is 3. We know 14 minus 3 is 11. Here is 11. Okay, so we define the coordinates of new origin. Therefore, coordinates of new origin are here minus 3, 11. Here is minus 3, 11. So by using old and new coordinates, we find the new origin. Okay, so very simple example related with this part, shift of origin. Let's go with next example for this part. Here in fourth, given, obtain the new equation of locus. Obtain the new equation of locus if origin is shifted to the point O dash to the direction axis remaining the same, okay. Here given one equation, here 3x minus y plus 2 is equal to 0. Here this is the equation of the locus, and this equation is defined by using the old coordinates. So by using the same equation, here we have to find the new equation of the locus, and for this we consider the new coordinates. Okay, so here by using the formula for shift of origin, we find this equation. So here I write first in solution by the formula of shift of origin. Firstly, I write our formula. Okay, here x is equal to capital X plus h, and here y is equal to given y, capital Y plus k. Okay, firstly we have to find the small x and small y. Okay, here capital X as it is, that is here x is equal to capital X plus, here for new origin O dash 2 is given, that is hk is given, here h is 2, so we get x is equal to capital X plus 2, and here for y, here capital Y plus, we know k is 2, so y plus 2. So we get here x is equal to capital X plus 2 and y is equal to y plus 2. Okay, so by using this part we find the new equation, and for this we consider this equation again. Consider here given 3x minus y plus 2 equal to 0. Let's replace this small x by using capital X plus 2. Here 3 into bracket x plus 2 minus. Now we replace this small y by using y plus 2. Here plus 2 is equal to 0. Let's multiply this first bracket by 3. If we multiply, we get 3x plus 6 minus. Now we apply this minus sign inside the bracket. Here we get minus y minus 2 plus 2 is equal to 0. Now here we know minus 2 plus 2 is 0. Okay, so in last we get here 3x minus y, then here plus 6 as it is, and this is equal to 0, and this is the new equation of the locus. Okay, I write here this is new equation of locus. Okay, so in today's lecture we go with the concept shift of origin. We see how to define the relation in between the old coordinates and the new coordinates. Then we see the formula for the shift of origin, and by using the formula for shift of origin we see 4 examples. Thank you.